So kia ora everyone, welcome to Auckland Bioengineering Institute, or ABI for short. My name's Alice Clark and I'm the Associate Director for ABI. That basically means I'm in charge of all things postgraduate, and I also have a research team here at ABI. Ordinarily at this time of year, we would invite you all in to have a look around the building and to see the work that we do. Unfortunately, the last lockdown in Auckland put a stop to all of that. So what we've done as we've emerged from this last lockdown is to put together some resources and some information and basically put together a tour of the building that we work in. So just quickly about what the ABI is all about. We're a large-scale research institute which is part of University of Auckland. The fact that we're a research institute means that we don't do a whole load of undergraduate teaching here. We mostly offer postgraduate degrees, but that means that there's all sorts of exciting research work going on in our building. So bioengineering in its simplest terms is the application of engineering to improve health or knowledge about health and physiology. And that kind of engineering can kind of cover a whole range of things, from mathematical modeling through device design and development of instrumentation, and right through to things like virtual reality. So today we're just going to do a whistle-stop tour through the whole building. You'll meet some of our scientists, some of our students. And once we've done that, please do hang around and ask any questions you have. If you come up with a question kind of mid-show, please just stick your question in the chat. We have somebody monitoring the chat today, and we'll make sure we try to get through all of the questions that we can at the end of this. So just hold off with questioning to the end if you can, but put stuff in the chat if you have anything that you think of as we're going. Okay, so let's get started. We're going to get going by having a look at some of our instrumentation research and our workshop facilities.
Kia ora, folks. Welcome to the ground floor of the ABI. My name is Brian Ruddy. I'm one of the researchers here, and I'm going to take you on a quick tour. So we're going to start out in the bay containing the biorobotics research group. This is my main research group, and here we develop medical devices based on robotics, and we develop new actuators that are needed to make these devices possible. So examples of some of the work that I've done here and I have students working on. This is a system identification machine that shakes the human shoulder, measures the force and displacement, and allows us to monitor the stiffness, and we can use this to look at recovery after injuries. Here's a device that we're very proud of. This is a robot that helps support the arm of a stroke patient after they've suffered that stroke and lost the use of it. By supporting the arm, we help them regain the use of it. They can do more, they can build strength, and ultimately recover faster. And this is an example of one of the motors that we've developed from scratch in order to power a device like this, which is not possible without a new motor. I currently have a new funded research project available looking at the architecture of motors specific in general and trying to create new motors inspired by biological muscle with liquid metal in the role of blood. If this sounds exciting to you, please get in touch. Next up, we have the soft robotics group. And this is an example of some of the kinds of devices that they use. This is a stretch sensor made out of soft silicone, and we can shine light down it. As we stretch it, the intensity and color of the light change, and we can use this to build a sensor that's made entirely out of squishy stuff. We don't need any wires or other hard parts to build that robot. So, moving on. Here around the corner is our jet injection research group. Here we investigate technologies for delivering drugs without the use of a needle. Instead, we have a high-speed liquid jet whose momentum is sufficient to go right through your skin. The injection is over in the blink of an eye. No need to fear the needle. Here's a quick demonstration of how this works. This is one of our injection devices. We've given it a low power battery so we can just show you how it works. I'll turn this on and you'll see a very fine jet come out of this ampule, and it's going about 10 times slower than a real injection. So this is quick, but imagine 10 times faster. So it's a bit like a really high-powered squirt gun, but takes no time and doesn't really hurt at all. We're looking at applications in dentistry, diabetes management, and even smoking cessation for this technology. Next is our optical instrumentation research area. Here we develop imaging technologies that work in 3 or even 4 dimensions, time and space, and look at different properties of materials while imaging them. Our final research area here on the ground floor is the Cardiac Energetics Research Group. Here we look at the fundamental properties of heart muscle. In particular, we figure out its efficiency by measuring both the mechanical work that it performs and the heat that it produces while it does that. These are very tiny pieces of heart muscle, less than a millimeter in size, and so we have to build exquisitely sensitive instruments to detect that heat and to detect the force when the muscles contract. So the instruments that you see here are the culmination of over a decade's work in this space, and we have lots more research left to do to figure out how the heart really works. If any of these areas interest you, I work on jet injection and biorobotics. Paul Nielsen works on soft robotics and optical instruments, and Andrew Taberner works on jet injection and cardiac energetics. With that, we'll go through to the workshop where Steve will show you how the facilities we have and what we can achieve.
Hi everyone, welcome to the ABI workshop. I'm Steve Olding. I'll just give you a quick guided tour of the facilities we have in the workshop. Over here we have a laser cutter and a micro welder. The laser cutter is a great piece of equipment for rapid prototyping of equipment, just to sort of get a feel for how your part's going to look that you want to manufacture, and then you can move on from there. Really great piece of kit. Further around here we have a water jet cutter. The water jet cutter is great because it removes the limitations of material that you can cut. So it uses high pressure water and garnet to pierce through pretty much any sort of material. We also have a manual mill and a manual lathe you can see James working on now. And these are also very valuable, not only for prototyping work, but also for learning how these machines and equipment work. From there, we move into the more high-end prototyping equipment. We have a 5-axis simultaneous milling machine and also a multi-axis lathe. These are great for more the finished product, I guess, and once the design is developed a little bit more, they become a lot handier. Also, we have a suite of desktop 3D printers through the building. Also a great rapid prototyping device. Thanks a lot for coming on the tour, and hope to see you soon. Bye.
Good afternoon, everybody. My name's Jenny Kruger. I'm on level 1 at the ABI, and we have many research groups here that specialize in medical devices. I work with the pelvic floor research group. I lead the pelvic floor research group. My background is actually nursing and midwifery, and I've been here at the ABI for about the past 10 years now. And my research is really focused around pelvic floor muscle function and dysfunction in women. I work with a group of engineers, and I love the idea of bringing engineering and clinical expertise together to solve problems from a different perspective. We have since created a medical device, which is now a registered medical device, and it's specifically designed to help women with pelvic floor dysfunction, and in particular urinary incontinence. We've created a spin-out company called JunoFem, which holds the licenses for a device called the FemFit. And we have been very fortunate that the ABI has provided some facilities to help us with our research. You can see I'm sitting here in a clinic room where we have not only availability to the devices we produce, but we've got ultrasound machines and some other instrumentation, which you probably can't see, but it's in there in the distance. It would be wonderful to see some of you here in person in the not too distant future. Thanks.
Hey guys, I'm David Budgett from the Auckland Bioengineering Institute and the Implantable Devices Group. One of the cool devices we've got is this chap here. So this is actually a left ventricular heart assist. So it's actually an artificial heart, and it's got a motor in it and an impeller inside. It'll suck blood down through this tube out of the left ventricle, and it'll be pushed out of this exit port and plumbed back into the aortic arch. And that requires quite a lot of power. So whereas a pacemaker, you put that in, its battery will last perhaps for 10 years or so. That same battery would only run this pump probably for about 10 seconds. So really running it off a little battery is not an option. If you put in a car battery, implanted a car battery inside a person, that would run the pump for about a day. So implantable batteries is a challenge for heart pumps. So the solution I've got right now, you can see a few wires hanging out of there. That goes into a cable, and that cable literally tends to exit about here. And then it comes out and it goes into batteries and pump controllers on the outside. And it's providing full cardiac support, so the patients are much better off because they're at end-stage heart failure. Their natural heart can't do the job. But they've all got this cable hanging out of them, and they're all getting infections. And they manage those infections the best they can, but it is a real problem for patients with these heart pumps. So what we're working on is how to provide power, energy to these heart pumps using inductive power transfer, wireless charging. So here we've got a coil. That's the sort of coil which you would need to implant under the skin. And then with another coil on the outside of the skin, in this case it's on the other side of this piece of glass. When you put those two close together, electrical power is transferred between them and enough power to actually drive a heart pump. So that means you don't have this cable hanging out, you don't have the risk of infection. So that pump I showed you, that's this one here. That one has been, this model has been in youngsters as young as 10 at the Starship Hospital. But then really the patients need to be of an adult size because it's quite a big pump. Here's the latest pump we've got. This little one here. So this one is by a company out of Houston called Procerian, and it's very, very small and very, very thin. Now it'll only provide 2 litres of support, whereas the other one provided 5, but 2 litres can make a real difference. And it's so small, you can literally poke it into the femoral artery in the leg. And if you keep poking up the artery, where do you get to? You must get to the heart eventually. Then you've gone a little bit too far, pull it back down again. This one sits in the descending aorta. And because it's so easy to put in, you don't have to crack the chest open, you can actually put it into patients who are not quite as sick. They're not at end-stage heart failure. And that means that their needs for high volumes are reduced. So 2 litres per minute is what it can do, and that's enough to help a whole lot of people. Alongside that pump, you can see here we've got our coil, which is their charging coil to provide it with power, and that's a power back, which does include a small battery, enough to run the pump for about half an hour, so the person can have a rest from having their charging coil on. They can go and have a shower, that sort of thing, or if it falls off, etc., they've got time to put it back on again. We can't stop these pumps. Once you've started them running, you've got to keep them running, because if they stop and they get clots in them, you can't turn them back on again because you can't have those clots being pushed into the body. So that's just an example of the sort of implantable devices we get involved in the Auckland Bioengineering Institute. We'd be delighted if you guys want to come around and have a look and have a talk about what we're doing. It'd be good fun. Cheers.
Hello, I'm Professor Ian Anderson, Group Leader for the ABI's Biomimetics Lab. For over a decade, our lab's been researching artificial muscle technology, the use of purpose-built electronics with soft rubbery devices. We call them artificial muscles because, amongst other things, they can change shape or produce force without a motor or gearbox. And there's all sorts of new promise in the new field of soft robotics that we're researching. We've also found a way to harvest energy as you walk. So, in fact, we're looking for a PhD right now to help us drive this further. This PhD will be supported by one of our spin-out companies, PowerOn. To give you an idea of the sort of things that you can do with this and to show you what a PhD project looks like in our lab, I'd like to introduce you to Derek Orbaugh, one of our PhDs. Derek's using soft sensors that we developed to capture gestures from a scuba diver and use his gestures to command an underwater vehicle. By the way, the sensors are based on artificial muscle technology, and they've actually been manufactured by another of our lab's company spin-out, StretchSense. So please have a listen to Derek, and if you want to find out more about our graduate opportunities, check out our webpage at www.biomedeicslab.com. By the way, we're also advertising a scholarship for a master's student to investigate a way to make our senses even smarter. So come and join our soft robotics artificial muscle revolution. Take it away, Derek.
Hi, I'm Derek Orbaugh, and as Ian mentioned, I'm doing here a PhD supported by the Naval Research Group and in collaboration with the University of Zagreb. So I'm developing a hand gesture recognition glove as the one you can see right here. It has its electronics all embedded in here, which does all the processing and is a standalone product without any use of a computer. And it has 5 sensors, 1 on each finger. The sensors readings give me the position of where each finger is, and based on the movement and the position, I can determine a gesture. For example, an I love you gesture, an okay gesture, a thumbs up gesture. With an IMU that is embedded in the electronics, I can also get dynamics. For example, if I have a problem as it said in underwater in diving or communication, you usually move your hand like this, which is detectable with the IMU. These commands are sent to an autonomous underwater vehicle, which is a robotic drone that will assist a diver. I'm gonna show 2 videos now. The first one that I will be showing is a virtual reality environment, which we have developed here in the lab. And basically functions as a training platform to get to know how to use the glove and what gestures to implement and communicate with the drone. Challenge is to get these gestures to be recognized by different people. That with this technology, we have developed sensors to be able to recognize by different people, regardless of their size of hand. And the second video I'm gonna show is a test we did at in the ocean in Croatia. This was done with the group of Zagreb, which developed the drone, can be seen here underwater. And we have one of our divers using a dive glove with the algorithm that we developed in the lab. Here we can see how he performs certain gestures and communicate with the drone. And that would be all for me. So I'll pass you on to Samantha.
Thank you, Prof. Anderson and Derek. I'm Samantha. I'm from the Augmented Human Lab. And ABI's research includes the design of realistic artificial intelligence avatars, augmented reality systems, as well as assistive devices. And for the past few years, the Augmented Human Lab has designed a whole range of award-winning devices. And one of the examples is the project that I've been working on, which I call Prospero. It's meant as a chatbot to give you memory training when you are calm and relaxed. And so I have sort of a sensor which gets your skin conductance as well as heart rate variability, and that kind of helps the system to infer when you're calm and relaxed. And I'm also kind of wearing this bone conduction headset, which we can wirelessly communicate. The chatbot can wirelessly communicate with you. Another project that we're working on is what we call Curious. So it's a science education toolkit that we are trying to bring to year 7 and year 8 students all over New Zealand. And for example, here I have a conductivity sensor and also a water sensor, moisture or humidity sensor. And this whole toolkit is meant to help improve and really inspire curiosity in science for students. And we are having a national pilot this year, and we aim to have about 1,500 students in 30 schools across 6 regions. And hopefully in the next few years, we will have it, these toolkits, these sensors for each year 7 and year 8 students all over New Zealand. So these are just 2 projects that among the many projects that we have been working on. And do take a look at ahlab.org to look at the other projects that we are also working on. Thank you so much for joining us at Level 5, and we hope that you enjoy the rest of your tour.
Hi everybody, my name is Justin Fernandez and I'm one of the postgrad team members here along with Alice at the ABI. And what you've just seen is some nice examples of some of our world-class research into medical device development, our state-of-the-art bioinstrumentation labs, and some of our workshops where you can turn that into reality. But probably the best way to know what life is like at the ABI is to speak to some of our students and researchers. So let's hear from some of them now.
Kia ora, I'm Duncan Baki and I do a PhD in biomechanics at the ABI.
Hi, I'm Steph. I'm doing my PhD in cerebral palsy research.
Hi, my name is Debbie. I'm doing a PhD in cardiac modeling.
And welcome to what may in fact be the most important room at the ABI. We have our best ideas here. It is not a lab, it is a kitchen. And like most kitchens, it has a fridge, it has microwaves, it has tables and chairs and people taking breaks, but it also has, very importantly, a barista grade espresso machine. Now, this is essential because previously people took too much time to go out to different coffee shops and order a flat white and bring it back. And we don't have that kind of non-optimized workflow here. So now you can make yourself a coffee and return straight back to your desk or hang out with some friends in the meantime. Yeah, and here's the thing. I think that if this whole PhD thing doesn't work out, I could be a barista at this point.
Totally.
Yeah.
Yeah, I really enjoy the research that I'm doing at the ABI. I find it really rewarding, but I also love the fact that people come from all over the world to study at the ABI. There's a range of backgrounds and talents, and people bring their niche that they work in, and they learn from each other and we all end up upskilling and having lots of technical knowledge.
Yeah.
I totally agree. I think being a student at the ABI is really, really great. There's really great support, whether it be from your supervisors, from your peers, from people in other research groups. The supervisors here are extremely nice, extremely friendly and approachable. And if you don't like collaborating with people in your research group, there are a lot of opportunities to collaborate with people overseas. So the ABI has many great connections with places like London and America, as well as Belgium and France as well. Just this time last year, I was in Paris.
Yeah.
You were in Paris?
I was in Paris.
I was in Canada. I mean, Canada's cool, to be clear, but it wasn't Paris.
I was in New York and then I turned it into a holiday as well.
Wow, you know what, guys, rub it in. Anyway, right here at home, we also have a lot of really cool social opportunities. I'm part of the social committee and we run lots of stuff, from the somewhat mundane, we have drinks in here every Friday, we have themed lunches for various international and cultural, celebrations. To some more elaborate ones, we do sporting events, we've done rugbying, we've done footballing, we've done laser tagging, we've done croquet, and we also do more low-key stuff. We've had board game nights, quiz nights. We do a pub quiz at the University of Auckland pub, which is a lot of fun. As well as the big bashes, we have a midwinter formal, as well as the ABI Christmas barbecue, where we all take a bus out to Jackie Puna Beach and have a couple of brews and some sausages, throw in our bowl. It's a really good time. There's a lot of support at the ABI for getting to know your fellow researchers as people, as well as just research collaborators.
Yeah, so that's what we get up to here at the ABI.
Yeah.
Hope you guys enjoy the rest of your tour.
And maybe we'll see some of you next time.
Yeah, catch you here.
Bye.
Hello and welcome to Level 7. This is where we do a lot of work on computational physiology, and myself and my colleague Finn here are going to tell you a little bit about how that all works.
Hello, I'm Vinod Suresh. I'm a senior lecturer at the ABI and work on a number of projects that involve computer simulations of the human body.
So here at ABI, we're world leaders in the field of computational physiology. And what that means is that we're using high-powered computing to simulate important systems in our body, like the musculoskeletal system, the reproductive system, our lungs, our hearts, our brains, and even our GI tract.
I'm working on a number of projects that involve circulation and transport within the human body. I'm looking at various problems involving the lungs, the brain, the gastrointestinal tract, and even applying these techniques to study animals like digestion in sheep.
So myself, I'm particularly interested in my research about how we get oxygen from our environment into our bodies. So as grown-ups, as adults and children, we do that via our lungs. So I developed computational models of the lungs. But a major area of my research is looking at before we were born, and I'm leading an international project where we're looking to build the world's first virtual pregnancy, so we can understand a little bit more about how we grow before we're born.
My work involves collaborations with medical doctors, with physicians, and with biologists. So some of the work I do involves growing lung cells in the lab and then doing a number of measurements on those lung cells to understand how they work under healthy conditions, what goes wrong in disease, and how we can then use the information from our experiments to develop computer models.
So eventually one of the goals of our work here at ABI is to build a full virtual human. So that includes connecting up components of how our physiology works, from cells through the tissue to the whole body, and bringing together models of all those different organ systems that I've talked about before. So this will help us to treat a lot of diseases that are currently problems in New Zealand and worldwide. So if we understand a little bit more about how our body works from these computational models, we'll be able to do a lot better job of actually guiding and developing treatments for a number of medical conditions. And also these models aim to help us improve how we diagnose problems. So how we might do a better job of spotting problems with how our bodies work earlier.
We are applying the same techniques to understand how animals function as well. And a lot of our work focuses on digestion in sheep and cows, which is a major factor for the New Zealand economy. So using these computer models and our measurements, we can try to improve the productivity of the animals as well as their health. And this could have major benefits for the New Zealand economy.
So in summary, we think that the work that we're doing here will make a big difference to the world. And thanks for stopping here on level 7. We hope you enjoy the rest of your tour.
Bye.
Tēnā koutou katoa, ko Tim Ainsley toku ingoa, no Michigan Aho. Welcome to level 8 at the Auckland Bioengineering Institute. I'm Tim Ainsley. I'm a senior research fellow here at the ABI, and I do research in the gastrointestinal tract. I'm originally from Michigan, and I've been at the ABI for a little over 10 years now. And like I said, my research is focused on the stomach and the intestines, and how the stomach and intestines function in health versus disease. I'm specifically interested in the electrical control of the gastrointestinal tract. It's very similar to your heart, where each of your heartbeats is triggered by an electrical wave that sweeps through the heart and causes the contraction that pumps blood through your body. The stomach and intestines are very similar. There's electrical rhythms in your stomach that coordinate and trigger each of the mechanical contractions that's responsible for digestion. Now, I'm also part of the Bioengineering Institute, obviously, so bioengineering is a real core role of what I do, but I focus on a translational pipeline of research as well. We develop a number of devices, a couple of which I've got examples here. So these are some surgical electrodes that we place intraoperatively, collaborating with surgeons in the operating theater. And more recently, we've worked to develop an endoscopic approach. So these, again, there's 64 electrodes here. It's placed endoscopically, which means down the throat. So it's a minimally invasive option to record the electrical activity of the stomach. We've done this work in healthy patients and found that the electrical rhythms are very routine, very organized, and then looked at very severe disease cases, so patients with very severe nausea, vomiting, and other symptoms, and found a number of abnormal electrical rhythms. That's been a really exciting discovery, and it's been widely publicized in some of the top journals in our field, fortunately. And that's now allowed us to use this technology to look at new diagnostics and new treatments. So we're developing these new devices, pushing them into preclinical trials to show proof of efficacy and safety, and then into the clinic. It's really rewarding to work hand in hand with clinicians and see these devices that we develop in the actual clinic being used to better understand patient outcomes. It's one of the most rewarding aspects of what I do, and it's really that people focus, working with clinicians and working with patients. That's also something I find sets the ABI apart, is it's really well founded in people. It's a great group to work with, a very collegial atmosphere. And with that in mind, I'll pass it over to Vicky to talk about her research.
Hello, everyone. My name is Vicky. Kia ora, everyone. I'm a senior research fellow at the ABI. In my work, I combine engineering technologies and modeling to try and improve diagnosis and treatment of traumatic brain injuries, which is better known as concussion. So brain concussion is a very serious health problem, being the third leading cause of death. And things are more serious here in New Zealand, unfortunately, as we have the highest rate of traumatic brain injuries among the developed countries. So currently there is neither an accepted treatment options nor an objective diagnostic method for brain concussion. So our research aim is to develop a mobile phone-based diagnostic tool for brain concussion that can be used in the fields as well as in the clinics. The way we approach this problem is multidisciplinary, that is combining knowledge from various different disciplines and multi-scale. So I work with experts from a variety of different fields, such as MR physicists, neuropsychologists, neuroscientists, or neurosurgeons, as well as other bioengineers. So we are combining different data sets from different fields using a machine learning based approach. So this video shows one of the approaches that we are taking, where we can predict the actual brain deformation pattern after impact within a few seconds. So this can be a basis, this will be the basis for our phone-based app. So as a part of my role at the ABI, I also run our Tuesday seminar series, which everyone should check out. We invite some really interesting speakers to talk. For example, we invited Dame Professor Charmaine O'Connor, distinguished Professor Sir Richard Fall last year, who both gave a very inspiring talk to our staff and students. This year, we had a privilege of inviting Professor Sean Handy, whose influential modeling work shaped our government's response to COVID-19. So it was a really rewarding experience to learn how our research activities were used in such critical areas. So if you choose to study with us, you will have a chance to learn from these world leaders yourself. Lastly, what I find most rewarding about my work is that it gives me an opportunity to make real differences in real people's lives. By developing a diagnostic tool and treatment options for currently untreatable diseases like brain concussion, we can bring hope and benefits to millions who are suffering from these conditions. Another rewarding aspect of my work is that new and exciting challenges that come up almost every day, which makes my life very busy, but very interesting. So it certainly is good to be able to have your passion as your job. Thank you.
Hi, everybody. As you can see, the ABI is a great place to turn your ideas into commercial outcomes. And we always encourage our students and researchers here to be very entrepreneurial. The ABI also has a great record of turning many of these ideas into commercial spin-out companies. So let's take a ride upstairs now to see our incubator, commercial incubator, Cloudnine, and see what's happening.
So welcome to Cloudnine, which is level 9 at ABI, the Auckland Bioengineering Institute. I'm Dr. Diana Siu, and I am the Strategic Partnership Lead at ABI. So let me introduce you to Will Hewitt, my dear friend here, who's also a co-founder of one of the startups in the Cloudnine space. Now, Cloudnine is ABI's startup community within the Institute, and we set this up in November 2019 to really nurture our fledgling companies all together in one space. Here, our spin-outs are able to continue to grow their businesses while they are still closely associated with their research groups and until they're mature enough to move out into the next steps. So ABI has had a long history of supporting startups from our research groups. And one of our most successful companies is Soul Machines, which makes digital humans powered by a digital brain from the work of ABI. Now, these digital humans are now used in many different industries, including, and New Zealand has used them, as well as some of the banks and more recently the WHO. So there are 18 startups that are associated with Cloudnine, and there are currently 10 that are part of the physical space. The rest, like Soul Machines, have matured and they have gone out into the real world. So the companies in Cloudnine currently are at different stages of growth, from 1 to 6 years old, and hence this is also a very safe space to share and learn and actually make mistakes together. So now, Will, tell me, you've been in Cloudnine since its inception. So what's special? How is Cloudnine special to you?
Well, Cloudnine's really helped in that it's, for myself as quite a young founder, given me the opportunity to learn from older, more experienced founders based within the space. It's given us a really good environment to grow, and it's sort of built out to meet our needs as a growing company, and it's been a real privilege to be part of the space and be close to our scientific advisors and other experienced entrepreneurs.
Thanks. And actually, I should just mention that Will is actually one of our youngest co-founders as well. And we're really, really happy to have him.
Thanks, Doug.
So now applying research to real life problems, whether in health, agriculture, or other areas, is really important for New Zealand to grow, not just economically, but also to benefit its people and society through new products and services. So commercialization is a route to ensure that the research completed does not just sit on the shelf and do nothing. ABI is able to offer students a glimpse of what you can do with your research and your skills, especially if you're interested in the commercial arena. So if this is something that you are keen on exploring, then ABI has the experienced people, infrastructure, and processes to help guide you.
I'm Dr. Hoidong Bai, the CTO of USJR. USJR is a startup company that has been incubated from the Empathic Community Lab of ABI, and we are currently co-located in Cloudnine. USJR mainly commercializes the research outcomes and delivers innovative augmented reality software and hardware solutions for industry partners. We provide consulting services to different organizations all over the world as well. We mainly investigate the collaborative augmented reality system and human-computer interaction on top of it to enhance a remote collaboration and provide face-to-face communication experience between remote people. Being a professional AR system solution provider, USJR commits to make augmented reality accessible for everyone. In the current COVID-19 era, many people adapt to work, study, or play from home and communicate with others by using video conferencing tools. We developed a 360 presentation technology for teleconferencing system to keep people's communication in a much richer and interactive way. Let me show you how it works. When you log into the system, you'll see the user interface is very similar to the Zoom. However, when you click the 360 window, you can actually pan around and see the live 360 panorama view in real time. You can also check the pre-recorded video in a 360 interactive way. Thanks for stopping the level 9 and enjoy the rest of the tour.
So we've made it all the way through the building. So I'm just going to quickly summarize the degrees that we have here at ABI and what types of jobs they can take you to, and then we'll move on to questions. The really, really eagle-eyed ones amongst you will notice that Justin and I have gained a student, Duncan, in between us. And so we're happy to take questions when we're done, just on both technical parts of ABI, but also what it's like to be a student here. So we offer 2 degrees currently here at ABI. Both are 100% research. The first is a Master of Engineering. It's 1 year full-time, and you can start either in December, March, or July. The second degree we offer is a PhD, which typically takes somewhere between 3 to 4 years. And you can start a PhD on the 1st of any month. We take on students from all sorts of backgrounds, not just biomedical engineering. So if you're not sure entirely whether your skills will fit with any of the projects that we have here, we're happy for you to just reach out to us and check whether your degree kind of fits with the work that we're doing. And so our graduates have gone on to all sorts of exciting roles. In New Zealand, that includes Fisher and Paykel and Rocket Labs. We've had students go to work for Apple and in various industries and universities overseas. So there's loads and loads of opportunities if you choose to do a degree with us for after your degree. So both our Masters and PhDs require an honours degree or equivalent. They have different GPA requirements. But if you don't have an honours degree, but you do have a postgraduate diploma or a master's degree, we're happy for you to get in touch and check whether you're eligible for those degrees. And the contact details for that are right down there on the bottom of the page that I'm sharing. So I'll keep that page up while we're asking questions in case anybody wants to write down that email address or the website details. And we're happy now for people to dive in and ask any questions that they might have.
Where's the chat window?
That's what I'm just trying to find.
Somewhere. Not yet.
Chat. So we have one question here. Do we have any scholarships? Yes, we do. So the University of Auckland offers scholarships. If you're a student with a GPA greater than 8, the University of Auckland would provide a scholarship. So what that means is that you would get your fees covered and a stipend, so a living allowance, which varies year to year, but is around about $28,000 to $29,000 tax-free. So that's money in the pocket. If your GPA is not greater than 8, there's no need to worry too much because we also have a lot of scholarships that we can offer from various grants that researchers have here in the building. So there are plenty of opportunities for scholarships, even if you don't meet that really high GPA requirement. And the best thing to do to find out about that is to contact us or to get in touch with individual supervisors who are advertising projects.
We have another question there. Someone's asking that they have a biomedical engineering degree from another country, in this case Nepal, and they have a GPA of 3.19 out of 4. So that's actually a different system to the one we use in New Zealand. The best thing for you to do in a situation like that is actually to apply online, and the graduate school will actually convert that to a grade point equivalent out of 9, and then we can assess you from there. So if you get more than 8, then you have a very good chance at a scholarship. If not, we have other funded opportunities such as grants and so forth. So the best thing to do is actually apply first, and the graduate school will assess your eligibility.
So we have, when are the application close-off dates? Well, those vary depending on what degree you're wanting to do. I think the biggest thing to be aware of is that it does take time to process an application. So for a PhD, you might want to allow 6 to 8 weeks of time to get assessed by the university, to design a project with your supervisor, and then to kind of get that approved and get a place. The master's degrees, we have scholarships that are attached to those master's degrees, and they do have deadlines which are advertised each year by the university. So for example, in the March intake, that scholarship deadline will be in around about January. So each year they kind of get released a couple of months before the start date. But yeah, if you just leave a month or 2, you would be able to have time to have your application process for the most part.
I also note there that Dr. Dai Siu, who's the person you saw, who's the director of our Cloudnine facility, she's just posted a comment saying that the ABI also runs internships and there's scholarships for those, especially for Māori and Pacifica students over summer. So if you're interested in any of those and actually getting an experience inside the ABI, please do contact us. There's a specific email here that you can also use. It's info@medtechcore.org.nz. So if you're interested in that, do follow that up.
So we've got another question here. Do you have any funded projects ready to start? Yes, we do. At any one time, we might actually have up to 20 projects ready to get going. We've always got supervisors who are really keen to take on students. And obviously, because our work spans various different areas, there may not immediately be something that you're that fit with your skills that's funded and available, but that doesn't mean that there won't be in a month or two from now. So if you keep checking out our website, you should be able to find some cool projects that really suit what you're interested in.
As you may have noted in the video, both Brian Ruddy and Ian Anderson, and probably others who I'm forgetting, mentioned that they had funded PhD projects ready to go and talked about some of the topics they'd be keen for. So, you know, if any of those caught your fancy, or if there's just anything you find on the ABI website for ongoing research areas, get in contact with people who are running those projects and see what they have. You never know what's going to crop up.
And what's it like, Duncan, to contact somebody to ask about projects?
Oh man, I had the delightful experience of being, I felt like the prettiest girl at the ball because I was talking to two professors at once, which is, you know, in some situations, something you're not meant to do, but, you know, and had to discuss the different possibilities for a project going forward. It was actually pretty great. You know, we had a few meetings talking about what there was funding for, what, you know, what openings there were in terms of ongoing projects that needed someone to carry this bit over this line or this bit over that. And so I actually originally started doing a master's project, which I then later converted into a full doctoral project because, you know, we started looking at it and going, this is really cool, but if we took it further, you know, if we took these same principles and applied it to a larger population or different pathology, what could that look like? So yeah, it's an exciting, sometimes slightly arduous process, but I can't recommend it enough.
And I think one of the most important things about finding projects is to look for something that really excites you. So you might be doing this for a while. So it's really important to it is actually really important to speak to multiple people if there's people with stuff that is interesting.
We got another question. Can we watch this event again online? Yes, you can watch this event online again afterwards. The entire thing's been recorded and it'll be all polished and edited together and put on the ABI YouTube channel. So subscribe and click that bell button if you wanna see it when it comes up.
I should add too that in addition to all the funded projects you see advertised, if you're really interested in just exploring something that potentially has some commercial links, perhaps to one of our Cloudnine companies, they can actually explore opportunities to fund you through a scheme known as Callahan funded scholarships. So some of our industry partners have access to scholarship funds in addition to the normal scholarship rounds. So do get in contact with us if you have any kinds of ideas and you'd like to do something especially connected to a company or that's entrepreneurial. Okay.
Great. So do we have any other questions? Here's your opportunity to unmute and throw out a question. If you, for masters, can we come up with the project ideas that we can?
Or just do the project.
So I guess that kind of comes down to the difference between a funded project and a project that doesn't come necessarily with a scholarship offered by the supervisor. So if the supervisor has a scholarship to offer, often that will be because they have some funding to do some research. So what that means is that research will have deliverables. There'll be things that they need to achieve in a set amount of time. So there's a little bit less movement there in terms of the problem that you might study, although there's often a little bit of kind of discussion with the students that come along about how exactly that problem might be solved based on different people's experience. If there is often students come with funding from elsewhere, or if they meet those GPA requirements for the university scholarship. And in that case, it's all about finding a supervisor that has research in the area that you're interested in, or is able kind of intellectually to supervise that project. And in those cases, it really comes down to reaching out to contact those supervisors and see whether they're able to help you out, especially if it's a little bit different to the work that is being done in a particular group.
Hopefully that was helpful. Just keep in mind though that even if the project is funded, all projects have a scope for some novel contribution, and that's the whole idea behind masters, but especially for PhD research.
Yeah.
Okay.
We are racing right up to that 5 p.m. mark. We're going to get your questions in right now if you want to, or you can also contact people later on. There's all sorts of contact information available on the ABI website, so make sure you click through that and have a look through all the projects and people.
So we have a comment here from one of our viewers that don't forget to visit the Art of Bioengineering art exhibition, which is currently happening at the Auckland Central City Library. It's going to be there for the next couple of weeks. And it's a really good example of some of our creative sides of our research. So a lot of our students, they also get involved in communicating their research in a very creative way. And so this is a chance for you to come and check that out and also ask some questions about their research at the same time.
Mm-hmm.
Yeah, so although this year has been quite difficult for us to have people physically come in the building and actually try out our devices and play around with our computer models, that art exhibition will give you a sense of the kind of work that we're doing here that might go a little bit beyond the tour that we did today. And often when you start speaking to supervisors, they'll invite you in anyway and let you have a little tour of the building, but just not with the hundreds of people that might be around the place during a real life open day. So we do welcome people into the building to have a real look around. Yep, and now we just had another comment from our viewers. Under level 1, you can actually arrange a visit.
Mm-hmm.
So we're not as restricted as we might have been a couple of weeks ago.
Mm-hmm. Yeah, I can tell you actually people start touring our level all the time. Tor comes around with people, Justin comes around with people going like, hey, and this is Duncan, he's doing, what are you doing, Duncan? And I have to do it, impromptu quick chat about what I'm doing. But I really enjoy it. So if you're keen on that, or anybody else, you should probably do musculoskeletal stuff. It's the coolest. Come over and have a chat, check it out.
One of the coolest.
One of the I think it's
pretty cool.
Pretty cool.
All right, so if we've got no more questions, we'll just leave you here. So if you visit our website, you can easily sign up for our mailing list, or you can follow us on social media. We have Twitter accounts, we have Facebook accounts, Insta, everything. Thanks. So you'll hear about more of our events there, and also contact us at that email at the bottom of the page if you want to know more.
So look forward to seeing you guys in the near future.
Thanks for joining us.
Thanks for coming.